Yesterday in class we took a lot of notes on exponents. We reviewed what to do when you are multiplying exponents with common bases, power to a power rule, raising to the first power, raising to the zero power, and negative exponents. Today we're going to go a little further. We're actually going to solve equations with fractional and negative exponents and even go a little further than that in a couple pages. So I want you to take a minute, pause the video, write the notes at the top, and then come back and we'll go over them. Okay, now that you have the notes written, let's go over and see what you wrote. It says what you need to do is you have to isolate the expression containing the exponent. Very similar to when we worked with radical equations and absolute value equations. You had to isolate those guys first. Well, the same thing here. And then what's new is you're going to raise both sides to the reciprocal power because you want to undo the exponent. And the only way to undo an exponent is to raise it to the reciprocal power. Well, let's think about why we're going to do that. If we take it, let's say a fraction, 2/3. And we actually are going to, and I'm not going to raise it, but I'm just going to draw an arrow because they don't equal. Raise it to the 3/2 power. Do you agree that 3/2 is the reciprocal of 2/3? Now, if it was actually x to the 2/3 and we raised it to the 3/2 power, you would have to multiply the exponents because that's the rule. Well, 2/3 times 3/2 is 6/6, which is 1. So basically you're trying to get the exponent down to a 1 because anything raised to the first power is that base. And that's what we're trying to do. And then they want you to solve the resulting equation and check your answer in the original equation. It says, recall to solve radical equations, we isolated the radical and then squared both sides of the equation. This is the same procedure because a radical can be written as a half power. And the reciprocal of a half is 2. So if we raised a half to the second power, we'd have 2/2, which is 1. All right, with that being said, let's take a look at number 1. With number 1, what we're going to do is we're actually going to isolate the base and the exponents. We're going to add 1 to both sides. I'm not going to show it, but if you want to show adding 1, you're more than welcome to. So then we're going to have x, whoops, let me get my stuff together here first. Sorry about that. We're going to have x to the 2/3 equals 25. All right, I need to get rid of the exponent because the base is now isolated. So I'm actually going to raise that to its reciprocal, which is the 3/2 power. But you know the rule in algebra, whatever you do to one side, you have to do to the other. So I'm going to raise that one also to the 3/2 power. Well, on the left, 2/3 times 3/2 is 6/6, which is 1. So basically I have x to the first, or plain old x. So now I got x by itself. And then I'm going to take out my calculator and go 25, caret, parentheses 3 divided by 2, close parentheses, enter. And I'm going to end up with 125. Now we want to do a check. So get your calculators ready again. We're going to go 125 raised to the 2/3 power. So 125, caret, parentheses 2 divided by 3, close the parentheses, minus 1, enter. Did you get 24? You should have. If you got 24, that means it works. So 125 is our answer. All right, let's go on to number 2. First things first, we have to isolate the base and the exponent. So we're going to divide each side by 2. So I'm going to have x to the negative 1/3 equals 3. All right, the base and the exponent are isolated, so we've got to get rid of that exponent, so we're going to raise it to its reciprocal. Now, reciprocal means to flip it. It doesn't mean to change its validity, what it is. The original is a negative, so its reciprocal is also going to be a negative. So we're going to raise it to the negative 3/1, or just to the negative 3rd power. And so we're going to raise the right-hand side to the negative 3rd power. So a negative 1/3 times a negative 3 is a positive 1. So on the left we have x to the first, which is x. And on the calculator, 3 raised to the negative 3rd power comes out to be a decimal. What we want to change it to a fraction, so it's 1/27. Just to save a little time, I'm going to tell you if we put it back into the problem, it does check. All right, with that being said, let's move on to another couple. We're going to skip number 3 for now and go to number 4. Number 4 is kind of big. Our exponent is 3/5, but our base in this guy is a binomial. So we have to get that base, which is 3y minus 4, to the 3/5 power isolated. All right, so we're going to add 4 to both sides. We will have 2 times 3y minus 4 to the 3/5 power equals 54. Still don't have that base isolated, so we're going to actually divide each side by 2. And we're going to end up with 3y minus 4, the whole thing raised to the 3/5 power, equals, on the calculator, 54 divided by 2 is 27. Now our base is isolated with the exponent. Remember, in this case, the base is a binomial. It's encased in parentheses because the whole parentheses, what's inside, is being raised to the 3/5 power. So we're going to raise it to the reciprocal power, which is 5/3. And whatever we do to one side of an equation, we have to do to the other. On the left, we're going to end up with 3y minus 4. On the right, 27, caret 5 divided by 3, close the parentheses, enter, you get 243. I still don't have y by itself, so I'm going to add 4 to both sides. We're going to get 3y equals 247. We're going to divide each side by 3. Y in this case happens to be 247 over 3 because it becomes a long decimal, and we don't want that, so we keep it as a fraction. Again, to save time, I will tell you, if we plug that back in, it does work. We're going to save number 3 for you to do on your own and bring to class tomorrow. Let's move on. Okay, now we're actually going to solve exponential equations. There's a little difference here for what we just did. What we just did before is we only had one base with an exponent to get rid of. Now we have bases and exponents on both sides of the equation. So the process is going to be a little different. Pause the video again, copy the directions, and then come back and we will move on. All right, now that you have everything copied, let's see what the directions say. Express both sides of the equation as powers of the same base. So basically, you're going to try to find the same base. Set the exponents of the common bases equal to each other. So for example, if x to the a equals x to the b, then you can drop the bases because they're the same and set the exponents equal to each other. Solve the result of the equation and then check your answer. All right, let's take a look at this. With number 1, ask yourself, do I have common bases? And we do. So if I have common bases, what I can do is drop the bases and then just set the exponents equal to each other. So I have x squared plus 4x equals a negative 3. It's a squaring, so the only way I know how to solve an equation with the squaring is to get one side equal to 0. So I'm going to add 3 to both sides. So I'm going to have x squared plus 4x plus 3 equals 0. I can't GCF, but I can go to 2 binomials. It's an x and an x. I need factors of a positive 3. That'll give me a positive 4. You're correct. It's a plus 3, and it's a plus 1. T-bar. X is a negative 3. X is a negative 1. So I need to actually check both answers. So take your calculator out. If we're going to check both answers, we're going to need to plug negative 3 into the x value of the exponent for the left side and see if it works out to be the guy on the right side. You're probably going to want to put 4 to the negative 3rd power into your calculator. So let's see what that is. So if I go on my calculator and I do 4 caret parentheses negative 3 close the parentheses, I get 0.015625. If I make it a fraction, it's 1 over 64. So now let's plug negative 3 into the left side to see if I get 1 over 64. So it's going to be 4 caret parentheses, negative 3 squared. So again, I'm going to need another set of parentheses, negative 3 close parentheses squared, plus 4 parentheses negative 3, close the parentheses for the whole exponent, hit enter, math fraction enter, and I get 1 over 64. So negative 3 checks. So you're going to want to do the same thing to negative 1. So pause the video, do it, and come back and let's see if that one works. All right, hopefully you found out that plugging in negative 1 also equals 1 over 64, which is the right side of the equation. So both answers do work. All right, with that being said, we're going to save number 2 for you also to do for a little bit of homework tonight and bring to class with you tomorrow. We're going to go move on to a couple more examples. Taking a look at number 3. I don't have a common base, so I need to find a common base. And this is a little hard because it's kind of hard to find a common base for a fraction and an integer. But is there another way I can write that base So it's an integer instead of a fraction. Put your thinking caps on. Let's see what you come up with. You are correct. It would be 9 to the negative 1 power. And that would be raised to the x. And then we have 27 raised to the 1 minus x. So 9 to the negative 1 power really is 1 over 9, because remember what you do. To get rid of the negative exponent, you bring the base to the bottom, and the exponent becomes positive. So now really what I have is 9 to the negative x equals 27 to the 1 minus x. All right, I still don't have a common base, so I have to think of a base that I can use for 9 and 27. What number raised to a certain power will give me 9 and will also give me 27? You're correct if you said 3. 3 squared will give me 9, but that 3 squared is going to be raised to the negative x power. And 3 cubed gives me 27, and that's going to be raised to the 1 minus x. So we really can't drop the bases yet, because we're going to have to get rid of those double exponents. So with that being said, we're going to multiply the exponents because it's power to a power rule. So we have 3 raised to the negative 2x power. And we have 3 raised to the 3 minus 3x power. Now we have common bases. So now we can drop the bases, set the exponents equal to each other, and solve. So I'm going to add 3x to both sides and get x equals 3. So it practically solved itself. I need to check the answer to make sure it worked, and just to save a little time, I'm going to tell you it works. All right, let's go to our last problem of the night. 4 and 64 are not common bases. I need to find a common base for 4 and 64. Well, can I use 4? Is 4 raised to any power going to give me 64? You're correct, 4 cubed will be. So this is going to stay as 4 raised to the x squared, and 64 is 4 cubed. Now 4 cubed is going to be raised to the x plus 28 over 3. All right, that's an awful looking 2, sorry about that. So what do I have now? I have 4 raised to the x squared power equals 4 raised to the, I have to do power to a power rule, 3 times x is 3x. 3 times 28 thirds, if you put it in the calculator, it comes out to be 28. All right, I have my common bases. I'm going to drop them. I'm going to set my exponents equal to each other. And I'm going to solve. I have a squaring. The only way I know how to solve a squaring is to get one side equal to 0. So I'm going to move the whole right side to the left and get x squared minus 3x minus 28 equals 0. I can't use CF, but I'm going to see if I can factor in t-bar. Factors of a negative 28, that'll give me a negative 3. You're correct. It's a negative 7 and a positive 4. T-bar, x equals a negative 7. I'm sorry, a positive 7, my mistake, and x equals a negative 4. So that's a positive 7. All right, I need to go back and I need to plug them in to make sure they work, and just to save a little time, I'm going to tell you they both work. If you want to practice checking, it may be a good idea. You might want to make sure that they both work, but they should, and if you can't get them to work, bring any questions you have to class tomorrow. Okay, don't forget to do the 2 tonight that I didn't do and bring them with you. See you in class.